Now let us see one typical problem from the chapter projection of planes. The question is, an isosceles triangle with base 40 mm and height 70 mm is resting in HRP on its base such that its top view is an equilateral triangle of sides 40 mm. Complete the projections of triangle if base is inclined at 30 degrees to FRP. We know while solving every problem on projection of planes, we do not imagine the solution at the start after reading the problem. The first step we do is to write down the data given, which invariably consists of three things. And the first thing in the data is shape and dimensions. In our problem, the shape is clearly mentioned with the dimension. The shape is isosceles triangle having dimensions base 40 mm and height 70 mm. So we have written down the first step, shape and dimension, isosceles triangle, base 40 mm, height 70 mm. Additionally, we usually draw a rough drawing of the shape also, and we nomenclature that rough drawing. It helps in further step of completing conditions with HRP and FRP. So in this case, we have drawn isosceles triangle ABC with base 40 mm and height 70 mm. Now the second thing in the data is condition with HRP. And we know in condition with HRP generally two things are there. The first is something of that shape would be in HRP, either corner or edge. And the second thing of condition with respect to HRP is the angle made by edge view with HRP. Now let us see what the first condition with HRP given in the description is. The isosceles triangle is resting in HRP on its base, and in our rough drawing we have specified AB as base. So the first condition with HRP is base AB in HRP. Now the second condition with HRP is angle of the edge view with HRP. In all the previous problems, this angle was given directly, but in this problem this angle is given indirectly. That's why this problem is typical. And if you read the problem, how this angle is given indirectly, we can interpret it. The isosceles triangle is resting in HRP on its base such that its top view is a equilateral triangle of sides 40 mm. This is the indirect way of giving angle with respect to HRP. We have to interpret this part of the problem as that given plane is at the inclination with HRP with such an angle that after that inclination its top view is appearing as equilateral triangle of sides 40 mm. So inclination is given in the form of end result of shape of the top view. So inclination is such that after that inclination top view is equilateral triangle. Now how to complete this step we will see in the solution, but this thing is important to figure out, and that's why this step makes this problem unique and typical. In this problem, angle of edge view with HRP is not given directly, it is given indirectly. And lastly, we do write down condition with FRP, which is in our problem given directly. Complete the projections of triangle if base is inclined at 30 degrees to FRP. We have specified base as AB. So as per the condition, base AB is inclined at 30 degrees to FRP. So we have figured out all the data given, all the data required for the solution in our problem, and this step is critical. If we could not specify or if we could not interpret any one of these things, the solution would not be there. Now after having entire data at our hands, now we'll go for the solution sequentially. Our usual sequence is, in first step we draw true shape, that is isosceles triangle and dimension, and the thumb rule is while drawing this true shape in the top view, we draw that element on the left hand side which is kept in HRP. So even though in rough drawing I have drawn isosceles triangle in this manner, in the solution in the first step I will not be drawing isosceles manner in this orientation, because in this orientation corner A is remaining free on the left hand side of the drawing. And as per the condition with HRP, condition with respect to HRP is of base AB. So this isosceles triangle need to be drawn in such a orientation that this base AB remains free on left hand side. Now let us see. Okay, so this isosceles triangle would be drawn in horizontal orientation. That's why base is remaining free on the left hand side and this height is appearing as horizontal orientation. So this would be our first step, that is drawing isosceles triangle in true shape with specified or correct orientation. AB 40 mm, height DC 70 mm and this isosceles triangle. Now in next step we will be completing front view of this true shape, which is in the form of edge view, and that edge view we draw on this reference line. So in the next step we draw projections from B and A on the reference line, projection from C on the reference line, and this line AB point view till point C constitutes edge view. This is our second step. So this is the first data we have represented, true shape with dimension, its top view and its front view. Now in all earlier problems, our third step was to complete condition with respect to HRP. And condition with respect to HRP we had drawn third step at this location. We had, say for example, had kept this element which we have kept free on the left hand side in the HRP, and we had given inclination to this edge view as per the specification, and we had completed this third step of front view of edge view, and from this change front view we had drawn the change top view. This was our usual sequence of steps for all the earlier problems, but this problem is typical. While figuring out data I have specified here what is in the HRP, it is given. So AB we can keep in the HRP at this location, say, but inclination of edge view with HRP is not given. Inclination, had that inclination been given, we would have drawn that inclination and we would have drawn changed top view. So in this typical problem we will not be drawing third step here because it can't be drawn due to unavailability of angle. So here the data need to be concentrated. The data is the edge view is inclined such that the top view appears as equilateral triangle of 40 mm. So that data we have to use. We have to draw anyway inclination of that value of that angle such that the top view should appear as equilateral triangle. Now if you see, now available top view is the first top view, it is isosceles triangle. Now it has to appear as equilateral triangle here after its inclination with HRP, and the dimensions of equilateral triangle are given as 40 mm. And if you look here, this base AB is of 40 mm. So if you transfer this base AB here, and anyhow we will be transferring with the help of projector A point horizontally, B point horizontally, anyhow this one side of the triangle AB would be of 40 mm. And it is given that here the remaining sides of the triangle would be also 40 mm because it is an equilateral triangle of 40 mm. That's why we will be drawing our third step here, that is projecting this base AB 40 mm and completing other sides of equilateral triangle as 40 mm. So in the third step, this isosceles triangle gets converted into equilateral triangle of 40 mm. So this side is 40 mm, this side is 40 mm, this side is 40 mm. And from this top view, now we will draw this changed front view. Now from B and A, if you draw the projector, we will get the location of A and B in the HRP. Now we are considering front view, and we know that AB will be in HRP because base AB is given to be existing in HRP. And we will draw projector from C, and on this projector somewhere point C would be lying, and the distance between this probable location of C and this AB, which is in the HRP, this length would be equal to length of this edge view, because in our usual procedure we do not change this length of edge view, we simply give it inclination. So in reverse manner, we will first plot AB here, projector from C, and the exact location of C would be taken by the compass with distance of edge view in the previous front view. So the fourth step would be completed in this manner: projection from AB and projector from C, and this length of edge view we have taken from this side. So the complication in this problem is at this stage. Here inclination was not given, shape after inclination was given. So we completed shape after inclination, and then we have found out the inclination. Actually we have not calculated how much is the inclination. Had it been asked, we would have calculated. If it is asked, you do calculate. Otherwise, no need to calculate and write down that angle. So with this step we have completed condition with respect to HRP also. And the final step in the problem is completing condition with respect to FRP. Now that step is of usual manner. Condition with respect to FRP we do complete by constructing new reference line at the side of top view. So if you construct any new reference line in the top view, it would be a FRP, but this FRP will not be constructed at any location. It will be constructed at the as per the given data, and the given data is base AB is inclined at 30 degrees to FRP. So this FRP will be constructed in top view at an angle of 30 degree to this extended base AB. So this is the construction of FRP at given 30 degrees with base AB. And the final step would be to draw this final front view, that is to project these points A, B, C in this new view, and while transferring these points in this new view, we do take distances from next to adjacent plane. That is, we want distances or points in this plane, so we take distances from, we will skip this plane and we will take distances from this plane or this view. Distance of A and B from this view we will transfer here. Distance of C from this reference line we will transfer here. That would be the next step. So this is the last step, completion of final condition with respect to FRP. So even though the problem is typical and slightly complicated, the number of points need to be projected is less, and this would be the generally case. In earlier problems we had pentagon or hexagon where 5 points, 6 points needed to be projected, but in this problem we needed to project only 3 points, but this less amount of points needed for projection is compensated by complication at this stage. So always remember, you can by heart also, isosceles triangle can be seen in the change view as equilateral triangle, and we have to find the inclination. The same thing will be the other shape, that is, if there is a rectangle here, okay, then you can visualize or you can imagine this rectangle can be seen as a square with unspecified inclination. So this problem is a combination of isosceles triangle and equilateral triangle. Similar problem could be there of rectangle here in the true shape and in the change shape square with the given dimension. The sequence would be same as of this particular problem. So this would be the general rule. If number of points are less, problem would be typical. If number of points are more to be projected, the problem would be simpler.